Good day to all. This particular presentation is related to pressure and its measurements, which is coming under the subject fluid mechanics and machinery. Before that, myself, M. Samuel James Prey, working as assistant professor in the Department of Automobile Engineering in Hindustan College of Engineering Technology, and this is about my portfolio. Basically, we all very well know about pressure at hopes. I hope. Yeah, pressure means force acting per unit area, especially since we are considering the fluid. So, this is pressure exerted by a fluid on a surface of any container. So, which is designated with P, which is equal to F by A. Pressure is of two different types. One is static pressure, whereas the other one is dynamic pressure. Static pressure is the thing when the system is under pressure or the pressure is under a constant and it is not varying, then it is known to be a static pressure condition. Especially the balloons which are filled with air is a very good example for static pressure condition. In case of dynamic pressure, we have numerous examples, but as shown in the picture, the tires which are also known as pneumatic tires, which contains air inside it, which is a fluid. So when the tires are in motion, so because of the same air pressure is varying inside the tire. So which is a good example of dynamic condition. This dynamic pressure. Generally, when we talk about units of pressure, it is designated with Pascal or bar Newton per meter square. But in general, one atmospheric pressure is equivalent to 14.7 psi, that is square inch, or 101.3 kilopascals, or 760 millimeters of mercury, or 10.3 meters of water, or 1013 millibar. Here for conversion, the reference is shown there. 1 pascal is equal to 1 newton per meter square. 1 bar of pressure is equal to 1 into 10 power 5 pascals. Then about the classification of pressure measurement systems, there are two different methods. One is based on mechanical systems, whereas the other one is based on electromechanical systems. In this particular presentation, we are going to concentrate only on mechanical systems. Again, as we discussed in the previous slides, pressure can be of static type or dynamic type. Here, the static type of pressure measurement is done using manometers, and some of the types are U-tube manometer, well type manometer, and inclined manometer. And in the other side, we have some measurements tools for dynamic pressure, and the dynamic pressure measurement is done using three different type of methodologies. One is diaphragm type gauge, second thing is bellows gauge, third thing is Bourdon tube gauge. Whereas the diaphragm type can be further classified as per its construction as flat diaphragm, corrugated diaphragm, and capsule diaphragm type. Similarly, the Bourdon tube also can be classified based on its construction as C-type Bourdon tube, that is the basic type, helical type Bourdon tube, and the spiral type Bourdon tube. So this particular picture shows us the different type of manometers used in regular practice. The very first thing is known as U-tube manometer, which is the simplest of the all. Second thing is the well or reservoir type manometer. Third is inclined manometer. Fourth one is mercury float manometer, which is necessarily the same construction, but the values can be easily measured using the graduated scale. The basic form is U-tube manometer. So this consists of a U-shaped glass tube which has the manometric fluid in it. The manometric fluid may be the two different standard fluids, that is liquids, that are water or mercury. So that is what's shown there. The advantage of using these fluids are they have the mass density which can be easily obtained, and they don't stick to the tube. Here the measurement taking method is shown in the image here. So one tube is connected to the pressure to be measured, and the other is held open to atmosphere. So the height difference can be calculated by pressure applied on one side, which is comparable to the atmospheric pressure on the other side. And we are very well know about the rho and g value of mercury and water. So by applying the particular value, very easily the pressure variation can be measured. So that is what shown in this particular slide. And next type of manometer is well type manometer, which is essentially the same kind of methodology, but here in order to improve the sensitivity of pressure measurement, the well or the reservoir is additionally used instead of the plain U-tube setup. So this is not the particular well type manometer is basically inconvenient to use, so it is not much used, and which has a good capability that even the smaller measurements can be easily measured in this particular case. Yeah, here we have the inclined tube manometer, which is shown in this particular image. So this is used in places where space is a major restriction. The methodology adopted here is also the same. Next, we are moving on to the dynamic pressure measurement devices, which are also known as force summing devices. The reason which it has the force summing devices tag is here the force acting on a particular body is summed or magnified. So commonly used methods are diaphragm type, bellows type, and Bourdon tube type of gauges. Basic type known as diaphragm type. So the diaphragm type of gauge is used to measure the pressure in very low ranges. Even it can detect pressure between a smaller variation of 0 to 4 mm. So this can be of flat type, corrugated type, or capsule type depending on the requirement. So the image shows the flat type, corrugated type, and capsule type. So this is the image animation which shows how the diaphragm gauge is working. So the diaphragm, when the pressure is applied on the diaphragm, it deflects, and the deflecting pressure is directly connected to a simple mechanism which is again moving as a needle on a graduated dial. By the way, the exact pressure can be measured. Next type of method what we are using is bellow type of gauge. In this bellow type of gauge, an elastic element is used to expand and contract when there is a change in pressure. Other than that, the diaphragm gauge and bellows gauge uses the same kind of basic principle, which uses change in its position with respect to the applied pressure, which results in a needle movement on a graduated scale. Thereby, the pressure value can be easily measured. So this is an animation which shows how the pressure measurement can be done with the bellows gauge. So the bellows setup is expandable and which is connected to a simple linkage mechanism with to a needle, and the needle moves on a graduated scale which exactly shows the value of the induced pressure. The Bourdon tube is the most common type of methodology used in current practice. This is the thing which obeys the Hooke's law. As we all know, within the elastic limit, stress is directly proportional to strain. So this is manufactured to be well under the elastic limit. So because of the same, when the pressure is applied on the Bourdon tube, the expansion happens and it deflects. And when the pressure is removed, obviously it returns to its original position as obeying the Hooke's law. So the basic type of or the commonly used type of Bourdon tube method is C-type Bourdon tube as shown in the image. So as the second image shows, as well as the animation shows, when the pressure is applied on the Bourdon tube, the open end of the Bourdon tube, which is made up of a metal with elasticity, very easily it is getting deflected. The deflection is directly connected to a mechanical linkage to a final pointer. The pointer is made to move on a graduated scale which is having a measurement of pressure values. This very easily helps a person to measure the pressure which is induced in the particular system. And the second type of pressure measurement tool based on board and tube is helical type. So the helical type of board and tube is highly used because of its high accuracy. Even the very smaller levels of inputs is directly converted um, to the graduation on the or the needle movement, which is highly helpful in accurate pressure measurement cases. Has a spiral Bourdon tube, so which is another configuration of the Bourdon tube method where the pressure can be easily measured using uh, the same methodology. Here, instead of a common C type of tube, a helical wound system is used, which is necessarily the same kind of elastic metallic tube. So when the pressure is forced in it, the metal is trying to expand. Because of the same, the center spindle is starting to rotate. This rotation is directly connected to a needle on a graduated scale, which can easily measure the values. So the helical as well as the spiral type of board and tube methods are little complex in nature, but it gives the maximum accurate value of pressure. With this presentation is ending. I hope this presentation highly helpful to you to learn something new. Thank you one and all. Thank you very much for listening.